Hi, it's Paul once again, and I wanted to demonstrate on something on this frinsi oscilloscope 100 megahertz. Now you see that beautiful sine wave there. It's from the function generator, the internal function generator. And you see some beautiful sine wave of 1 megahertz and 825 millivolts duty cycle, roughly 50%, 59 there you look here and there. And then let's look at the mains. I have a transformer here to step down the mains from the power supply. That's 240 volts here in my country. So since I have my probes are my probe here is I don't have the times 100 attenuation. My probe is maximum times 10. That means with this oscilloscope I can't be able to measure the mains directly. I could cause some damage to the oscilloscope. So if I had the 100x, I could be using it very well. So I'll not be using the I'll be using this these are a trick that you can use. You step down the mains because the waveform is going to be the same. So essentially I'm stepping down using this old transformer so that I can see the waveform. Is it truly sine wave like this one? Beautiful, as you are told that the mains has a smooth sine wave. So let's hook up our wires and see what happens. Let me remove the other ones. Let me unhook the other ones. I have these ones. Okay. Yeah. Now I've hooked my probe and my ground, and these transformers several outputs from the secondary side. So let's run the test. See, yeah, see that wave. Frequency it's 50 hertz. That's the VRMS. It's 7.47. Vmax is 9.69, and these are budget oscilloscope, and you can even save your images. Like I can save the pictures, and then you can always browse your photos. I can save the wave, and I can even check the details here, a little bit of the two channels. You can see the cycle time 20 nanoseconds, frequency for 9 hertz, and we have the V peak 9, VPP 19.6, VRMS 7.42, and you see all the details. So the thing is, these the mains is not that smooth sine wave because of there's a lot of noise. There's the harmonics, there are a lot of inductive loads on the line on the mains because these are national grid, so there's a lot of noise that's causing harmonics, and then that will result in some bit of distorted waveform like what you see. Coming close to a square wave, is it a triangular wave? Weird in between there. So basically this is what you get in practice versus what a true sine wave could look like. Is more or less like a modified kind of sine wave, but it's not really modified. It's a pure sine wave fundamentally. but due to other loads, a lot of harmonics, and there you have the distorted sine wave. So that's it, guys, just in case you're wondering what it could look like using an oscilloscope.